Hey you guys, this is Mr. Sal. We're going to look at this problem which was brought up by one of my YouTube viewers. So let's go ahead and jump in. Now there's a couple ways to do this. In my classes, generally the students like to see this as slope-intercept form. Now it doesn't have to be. You could use a table. But the slope-intercept form is nice because it shows us the y-intercept and the slope. So when we graph this, we can see a few more points than we would otherwise generally see from just graphing in a table, which usually only has 3 points, or 2 points even required to graph it on a computer or on the homework sometimes. In any case, let's go ahead and get started on this one. So I'm going to change this into slope-intercept form just with the inequality. And remember, we only flip inequalities if we multiply or divide both sides by a negative. The first thing I'm going to do is subtract 3x. Now that's not multiplication or division, so it doesn't actually change the inequality. It's going to remain a less than symbol. Now what this does is it means I can drop the y. The 3x minus 3x, that's going to zero out. Now I've got 0 minus 3x. These are not like terms, so I'm not going to combine them. I'm going to show this as 3x and then plus 0. Now you may be asking, well, why am I showing the plus 0? It's because it's kind of a formal slope-intercept form. What this does for us, this plus 0 here, is it shows us the y-intercept at 0, 0. So I know right away that I got a point there on the graph at 0, 0. Next, the slope on this one is shown as negative 3. Now I'm going to show it as negative 3 over 1. And what this does is it creates a pattern for us on the graph from the y-intercept, which is 0, 0. So from there I'm going to go negative 3. Now the negative would be down 3. So I went down 3, and the one which is positive is going to move me to the right 1. So from there I'm going to go to the right 1, and that gives me this next point. And then I'm going to continue this pattern down on the graph until I can't go any further. Now just notice this creates a stair-step pattern, and if I want to, I can move the steps also to the left, and that creates the pattern of the stair steps. And I'm just looking at the points that I created. Those are the lines that I'm going to connect. So this is my line, and we just have to be careful because this is an inequality. So we're not even, I would say we're not even close. We're even at least halfway finished. So what I'm going to do is I'm going to go into this thing, and we need to look at the inequality. So since it's a less than symbol there, what I'm going to do is I'm going to go into the graph and make it a dotted or dashed line. So I'm just going to kind of squeeze out some of that line right there, something like this, just to show that it's dashed or dotted. Of course, you do this a little different if you're doing it on paper, but I've shown that it's dashed right there. And yeah, I kept the stair steps. That's because it's I want to see the pattern. But now that I've dashed it, I need to figure out which side of the graph to shade. Now the shading indicates that everything in the shaded area would make the original inequality true, and all the points on the line make the point or make the original inequality false, which is why it is dashed. So I need to check this, so I'm going to go in to the original inequality, which is y plus 3x, and that's less than 0. And I just want to check to see if it's true, and what I mean by it is a point that I need to choose. So the point that I'm going to choose is, I'm going to choose one here on the right, not that it would matter, and that's the point 1, 0. So I'm just testing this point to see if it's true or not, and I'm going to go into the equation that I just wrote, and I see that I'm going to replace the x with the 1 value that I just got from choosing that point, and the y value is going to be replaced with 0. And then we're going to see if this is true or not. So I got to put a question mark right there. And to solve this one, 3 times 1 is 3. 0 plus 3 is 3. So is 3 less than 0? No, that's false. Now, since it's false, it means I'm going to graph, or on the graph, I'm going to shade everything to the left of that green dashed line. Now, you can crosshatch it, you can fill it in, whatever you want, just as long as you show that everything to the left of that line is shaded. And again, that means all the points in this area would be, or would make the inequality true. Now, that extends forever, so there are a large number of values that make it true. In fact, there's an infinite number. And that'll do it for this problem. So thanks for watching, you guys. I hope it helped you out. If it did, please make a comment below and subscribe to the channel and give this video a quick thumbs up. We'll see you guys in the next one.